video, as I said, we're going to be finishing the Unit 2 practice problems. The first video that you have watched will have everything done except for this question number 9. All right, so we're going to do that now. Question number 9, and we're going to take the time to type in these data values. You probably, I can't obviously guarantee it, but the AP exam, the College Board, is not really going to waste your time by typing stuff in, right? So this would be rare. When I say type stuff in, I mean like into like list 1 and list 2. It's rare that they ask you to do that. They obviously are going to make you do, calculator things, but it will probably not be like typing in these values. So we're going to first do this, and what I want you to do, we don't actually need it for this problem, but just so that we can do it again in case, again, the likelihood is minimal. But in case you want to do this, and we'll make sure you get the correlation coefficient letter R. Do you guys remember what you have to do first in your calculator to make sure that when you do a linear regression, you get the letter R? The diagnostic on, yes. So it's going to be the catalog, which is second 0. And then you can scroll down, or you can click alpha, which is the green button, to go to letter D, which is alpha, the matrix button, or x to the negative first power. There we go. And go to diagnostic on. Just a kind of reminder, again, the odds of you needing to do this are super low, but in case you want to have the correlation coefficient, you've got to make sure that has been done. And I'm going to clear all these calculators before you take the AP exam. So if you want to get this, you're going to have to do it on the AP exam in a few weeks. Yeah.
Should you just turn this option on at the start of the test?
I do, yeah. Like when I took it in high school, I did. I didn't need it, but just in case you need it.
And it won't affect anything.
No. Yep. Okay. So let's go ahead and type this stuff in. All right. Look at letter A. Can I see letter A for me, guys? If you look at it, it says, can average attendance be predicted from number of wins? So in our class, what I've usually done is I've let you decide what's going to be the X variable, the explanatory, and what's going to be the Y variable, the response variable. But this question is actually telling you which is which. All right. When they say, can average attendance be predicted? They're saying that the average attendance is the response, or the Y. All right. And the home wins is the explanatory. So we're saying the number of wins at home explains the average attendance for these NBA teams. Okay. Everybody all right? Okay. So I'm going to go to hit stat. And I'm going to hit edit. And in list 1, I'm going to put my X variable, which is home wins. So 34, 32, 21, 18, and 18. And just so you have some context here, if you don't know anything about the NBA, they play 41 home games. All right, so 34 home wins is winning most of their games at home. All right, they play 41 games at home and away. So go to list 2, type in the average attendance. All right, now once you have finished this, right, typing it in, the first thing I want to do, and I know you don't have to do this, but is I want to make a scatter plot. Do you guys remember how to make the scatter plot? I think Jonathan is in the hallway when he comes back in. Do you guys remember how to make the scatter plot?
Yes.
Second stat plot. I'm going to just do the first one. Turn it on. All right, and do you remember which one is the stat plot? Or excuse me, the scatter plot? It's the one that's already highlighted. So actually, as long as you have your explanatory in your L1 list and your response in your L2 list, you're actually good to go once you turn it on. So hit graph. And then zoom. Do you remember what number?
No.
Zoom 9, which is going to be zoom stats. All right. Now, this is pretty tough, guys. It's only 5 teams. right? So it would be much easier to describe what's going on here if you had all of the 30-some, whatever it is, NBA teams. I don't know how many anymore, okay? But it's a little tough here. But when you're describing a scatter plot, what 3 words should you be thinking about? I'm going to definitely strength. That's actually my last one. Not shape. Definitely strength is one of them. I say that one last. No, not resistance. So the first one I do is direction. The direction. Is this positive or negative? Thank you, guys. Appreciate it. So this is positive direction, right? Positive direction, right? The next one I do is form. Do you remember the words we described the form of the scatter plot?
No.
Really, it's just linear
Or not.
or not linear or non-linear. That's fine. Okay. What I've tried to teach you guys in this class is, unless it's like very, very clear that it's not linear, what word am I going to use? Linear, right? Because the idea is if it's not linear, I would have to do the re-expression that we learned in chapter 10, which is, taking the y values and squaring them, taking the y values and doing the square root of them, the reciprocal of the y values, then do logarithms. Like, you'd have to do a lot more work. So to avoid that, unless it's like very clearly not linear, I'm going to say it's linear. And the last one I always do is strength. I'm not going to do that for this one. It'd be tough to do with only 5 data values. Okay? So in letter A, it says, find the equation for the line of best fit. Another way to say that is to find the linear model, right? Find the least squares residual line. All these things mean the same thing. I'm going to hit stat, calculate, and I know it says linear regression in number 4, but I actually use linear regression number 8 for A plus BX. That's what I've taught you guys to use as well. So number 8. All right, I've got my list 1, list 2. You can store it if you want, don't need to. So this is my regression equation. So let's write it down. So average attendance. Do you remember what I have to put on top of that to show it's predicted? The hat, right, equals 12,415.5 plus 180.4 times wins. Now, what's most likely going to happen on the AP exam is they're going to give you all this information, and then you're going to actually have to start with the interpretation of this stuff. So like in letter B, you definitely will be doing this on the AP exam. How do we interpret the slope? Do you guys remember, like in general, like not specifics, how we interpreted the slope in the first semester? Yeah, Israel, you remember? Yeah, we cared about positive and negative. The way that I taught you guys is if you increase your x value by 1 unit, all right, so if you increase this x value by 1, I expect my y value to change by the slope. So Estrella, if it's a positive slope, I expect it to go up. If it's a negative slope, I expect it to go down. So in this case, with context, if I tell you the team won 1 more home game, what do I expect to happen to the average attendance? To go up by how much? About 180 people. So I'm going to write that here. So if a team wins 1 more home game, I expect the average attendance to go up by 180 people. Now, is that necessarily going to be true? No, right? It could go up by more than that, less than that, right? But the idea is based on this data, we're expecting that it will go up by 180 people for each additional home win. Now, it doesn't ask us to do this, but how would you interpret the y-intercept? The y-intercept is this 12,415 number. How would you interpret the y-intercept? Yeah.
If the team has no home wins, that's how many people we expect to be there.
On average, right, each night, right? And again, could that make sense in this scenario? I think it could, right? Hopefully your team, the home team, doesn't lose every single game. That would be unfortunate, right? And I would imagine if you do that consistently for many years, you're going to lose a lot of attendance, right? But the idea is that sometimes the y-intercept could make sense, and sometimes it won't. Any questions on B? Okay, C. Predict the average attendance for a team with 25 home wins. So what I'm going to do is I'm going to plug in where it says wins. I'm going to plug in 25. Now, I know that I'm breaking my rule a little bit here. I'm going to round when I do this. I just want to give you the practice of evaluating. So 12,415.5 plus 180.4 times 25. So we're predicting 16,925 point. I don't know why I put dollars. Sorry about that. 0.5. So in this problem, you're asked to actually use the model to predict what would happen if a team won 25 home games. All right, now the last question for this problem, letter D, says what is the residual for the I should really proofread my words, Lakers average attendance. Now, I guess my question is first, do you know what a residual is? What is it? Yeah, I mean, that's kind of what we're saying, right? In stats, we say that the residual is the difference between what actually happened and what the model thinks will happen. So there's a formula that we have, hopefully you have memorized. Residual equals, anybody remember the formula? Observed minus, I write predicted, but expected is fine. No, expected is fine. Expected is okay. I just write predicted just to continue with that use of the word predicted, but expected is totally fine. All right. I don't think that's on the formula sheet, so make sure you have that memorized. All right. So in the table, we actually have the Lakers' observed wins. How many wins did the Lakers at home for this year? 18,000. No. How many wins? How many wins?
34.
How many wins? So 34, right? So 34, right? We don't have to, Thomas, you're right, though. I am going to use that number because it's about the Y values. But I want to make sure you know that they're basically saying the 34 number, right? If we plug that in, we would expect to see what they got. But is it going to be exactly that 18,000 number? No, right? So there's going to be a little bit of a difference. So we put the 18,997 minus, and then to find the predicted value, so this is the predicted attendance, we're going to plug in, was it 34? 34. So let's plug that in. So do the same thing we just did, but instead of using 25, we're using 34. So 18,549.1. Okay, so if I subtract this, this will give me my residual. I'm going to get it in a moment, but what do you notice about those two numbers? Which one's bigger? The observed. So according to the model, for a 34 home win team, we're only expecting an average of 18,549.1. So according to this model, the Lakers actually outperformed in terms of their attendance compared to what we thought would happen. All right, so this is going to be 18. So the residual is 447